Hello. All right. How are you, stream? Okay, it's Tuesday. That means we're streaming. And what else? We're gonna work on our library that we've been working on in the last, I guess last week or so. Maybe last 2 weeks. Anyways, here we go. Let's blow up the screen for you. I think this is good enough. Oh, this I don't know. I always have to take a little time to get used to the huge font size. So let me show you what I added offline. I think the most significant change I made offline is delete. I implement delete, and if you follow me on Twitter, you'll notice that I posted some interesting findings regarding this. And the interesting finding, oh my god, this text is so big. Is it okay if I make it a little smaller? I'm gonna make it just a little smaller. I want at least something like 100 column on each side. So let me launch Vim and see where my guide is. So okay, so there's the guide. So this is 110. So 100 is somewhere in here. This, good enough. Okay. Okay. So this is how the delete function in Windows is implemented. It deletes a file or directory, and there's a single function in Windows that can do this for you to delete a directory, regardless of whether it has content or not. But unfortunately, the header that's shipped with the standard Swift distribution on Windows does not include that particular library, even though it is native to Windows. So I implement this going into the directory, delete all its content, and then delete the directory itself. But if you actually read the code, you'll notice something weird, which is we're actually moving the file to some place, and then we're going to delete that, the same location. We move the file to this temp location, and then we delete it there. So the reason for that is Windows actually mark a file as deleted, but it actually doesn't delete it immediately. What that means is if you're marking every file in a directory to be deleted, and you try to delete the directory is actually not empty because the files are still there. So that's why you want to move them. Move happens immediately, and then after that, you can delete them. Anyways, just a little weird, quirky thing about Windows. But along the way, there were a bunch of things that I realized actually are essentially because of that thing I just described. There's a bunch of things that really got implemented because of it, and therefore really the delete function depends on them. For example, things like moving something, this move file thing, and then things such as making a temporary directory, right? Finding the system temporary directory and deleting them. Sorry, did I say deleting them? No. Finding it and then return it to the user. Things like that. So let's look at that in terms of our tasks. This list grew a little bit as the day went on, and this done list is growing as well. But I think to warm ourselves up today, I'm going to implement that move ticket. Okay, so let's just jump straight in and call this move. And I'm going to try to... I installed the latest version of SourceKit LSP from the trunk snapshot for Swift. So I'm expecting some good Vim editing today. Okay, let's try it out. Let's do it for real. So I guess move should be sweet and simple. We just open up our path file and wait. So it should go to either path plus Windows, right? So for Windows and POSIX will have separate implementations. So the okay, so delete. Let's just put move here. Public function move to new path path, and then this throws. Oh, this is so good. This doesn't stutter, doesn't stop. In the past, in the older version of SourceGate LSP, it new Vim freezes a lot because it returns a huge amount of results in JSON format, and then I think the display thread on new Vim and the thread that parses JSON is the same thread. Therefore, the returned result actually frees up the editing. It's really bad. Anyways, I think this should be sweet and simple, as in we just need to do this, right? So this is, yeah, our source is binary string.cstring, and then our target is new path.cstring. If that doesn't succeed, we throw an error. That's it, right? I think that's it. Now, how do I test this? Yeah, I don't know. So I also added a new example amp, RM, which is remove, and it takes the -r parameter. If it's -r, it will recursively remove. If it's not -r, it will fail if your directory that you're trying to remove is not empty. And if it's a file, it will just remove it regardless. Yeah, I can keep adding new examples for move, for example, but maybe I just I'll do that thing where I temporarily edit a file using an example, right? I don't know which one to use. We'll just use makedir. So don't be confused. I'm using it, but I'm not checking the resulting. So let's write a super simple example. We imported pathos. So let's take the command line argument. Oh my god, this feels so good. And then we move it to a path created from command line arguments 2. That's it. We just straight up try this. Catch the error. Okay, so it's complaining that it doesn't have a move type. That's because we're on a POSIX system. So let's implement that as well. I think that's pretty simple as well. I think you just call rename, right? Let's see, man to rename. Rename takes 2 character arrays, and that's it, right? And it probably returns. Okay, if it's 0, 0 means success. So not 0, then we throw. All right, let's do that. Path plus POSIX. Oh, did I already open that? Okay. So let's put it down here. Public move to new path throws, and then literally just call rename. Binary string C string new path dot C-string. Maybe binary string dot C-string. Okay, so I think I didn't do that correctly. So if 0 means good, so if this is not 0, we throw system error with the code error no. Okay, so that should be that. Let's make the function keyword here. Okay, so I'm gonna go back to path plus Windows. Oh my god, this new version of SourceKit OSP is a game changer. So this should be new path binary string dot C string. Okay. Yeah. Now what? Now let's run the example app. Let's build it. Build everything. Okay. Now let's move. Let's move something. What's in temp? Okay, has some Swift format stuff. So let's move. Let's move it. So in the build directory, I believe debug. There should be a binary called. Was it makedir? Did we edit makedir? Yeah, makedir. So makedir. Okay. So don't be confused. Makedir is just a target I'm reusing for testing purposes. So first thing, let's try to move temp slash Swift format to, I guess, here. So 2 is like something doesn't exist or something. Okay, so interesting. We failed. Let me read the documentation real quick. So 0 indicates success, right? So in our code, I believe we're checking not 0 for throwing errors. POSIX. Oops. Not 0. Okay. We're trying to rename things, and error number 2 is, I think, path doesn't exist or something. POSIX error code. Let's read that PHP file once again. Famous. Google for some reason likes this a lot. So no such file directory. Interesting. How did this work in the current iteration of the library? Let's see. Go here. Manipulate. Whoops. Manipulate. Okay. There should be a move somewhere. Move. Yeah, it's the same implementation. Okay, interesting. And let's take a look at our sample app again. We move the first argument to the second argument. Looks okay. All right. Then let's go to the library implementation real quick. So move. Okay. Let's print out both of these paths. Moving from self to new path. Okay. And then let's run move. Oh, make dir temps slash Swift format. Okay, so input looks fine. So why doesn't this work? Again, this is the code. So it's possible that when we're feeding the C string, the value of the C string is wrong. How do we fix that? I guess I can just print So if I print this, I'll get... No, that's not good. So let's print something like string, say string, and find... Uh-oh. It's freezing up. That's not good. Okay, so this should work, right? Make build. Okay, it did build. All right. Oh, what is this? This might have something to do with the fact that I'm using a trunk version of Xcode, so I'm gonna ignore it for now. I don't know, but our target built. That's all that matters. So let's do the same thing for the new path. So if we're throwing this error, we're gonna take the C string value of these paths and convert them back into a string and make sure they look fine as well. So I guess we'll just run the same thing. Okay, so we're trying to move this to that. That looks fine. Again, the POSIX API in question is this. Rename old to new. Why wouldn't that work, right? Let's read the documentation together. So this system call causes the linked name from old to be new. If new exists, it's first removed. Both old and new must be the same type. That is, it must be either directory or non-directories and must reside on the same file system. Okay. It guarantees the instance of new will always exist if the system should crash in the middle of the operation. If the final component uses a symlink, the symlink is renamed, not the file directory it points to. Fine. Looks good. What's the problem? Okay, caveats. System can deadlock if a loop is running the press system. The loop looks at the form of A, say A full being a hard link to B, and the entry in directory B, say B bar being a hard link to A. Makes sense. Yep. Should the loop exist and two separate process attempt to perform and rename? Yeah. Okay. If we're making it a hard link to directory in an underlying system, be replaced by symlink system administrators. Okay. System administrators. Okay. In the old Linux tutorials, it always says, if you can't do X, contact your system administrators. I don't know if anyone here have seen that before. Okay. Anyways. So this is wrong. This didn't work, which is very strange. Wait, do I have absolute? Okay, so I can try to convert them both to absolute path. Wait, did I actually run the example after the C string conversion? Yes, okay. Okay, I can try convert both to the absolute value. So absolute new path absolute. Let's try this. I don't expect it to do anything though. Oh, try for sure. Yeah, because absolute require reading what is the path for current directory, so it is actually possible to throw an error. Okay, we got the same error, but is it because? Okay, let's do this. Source is this, and target be that. So this will be source.cstring. The other thing will be target.cstring. So both of these requires try, no problem. Let's just do that. Now I can print out from source to target. Okay. Not gonna lie. What is this? Oh, binary string. That's unfortunate. So as you can see, binary string literally is binary. So binary string. But like I said, I don't think this actually is the reason where this is not working. Yeah, we're moving from this to this. But this definitely exists, right? Yeah, it definitely exists. So I'm a little confused. POSIX move file. Rename. Move a file Linux in C. Usual way is to use rename, sometimes fail. You cannot use a rename system call because source and target different file system. Query the size, permission, other metadata, copy the metadata loop, blah blah blah. Yeah. Yeah, so if you can't do it, you can read the file and then write it to the same place and then set the same metadata. So yeah, I'm really confused because it's not like I'm using the wrong system call, but we're getting system number 2, which means the file doesn't exist, right? And to make it even worse, that's our current implementation is the same, and as far as I know, it works. And I'm not flipping the condition here, right? Yeah, I don't know. Let's test this on Windows first. I don't want to get myself stuck here. So what happened here? Okay, let's make one commit. Implement move, and then let's check this in a separate commit. Temporary use mixer as sample app. Okay, I'm gonna push these up. Okay, then I'm gonna. So I'm gonna try just SSH into the Windows machine. This way I don't have to switch things. Okay. Source, pathos, checkout, move. Okay. So first thing we do is enter the shell, create the shell environment. Then I'm gonna go to a better shell. Then run the build script. The build script failed because usually there's a temporary directory thingy that it's very annoying. So I'm gonna do users then app data local temp org and then module cache EYQ blah blah blah. Delete this guy and then I can build again. Oh hey. Okay, so we built, right? So now in this directory, Windows bin, we should be able to see a makedir. And then what was the example I was using earlier? Yeah, okay, let's just do something random here. Resources, releasing, let's do releasing. Releasing to releasing. I don't know. I bet this works. Yeah, on Windows, things are just working because we're using the proper Windows API for this. So we kind of verify that it works on Windows. That's a good thing. Okay. Nice. You know what? I'm happy we didn't totally exit. Let me try to rename something else. Let's rename a folder, okay? Resources to graphics. Yeah, that works too. Nice. Okay, so we're back to debugging. Why is this not working on POSIX systems? Any ideas? Paths, POSIX. Okay. We're calling rename, right? This rename is the version from the system. It's this guy, yeah. And for some reason, I got a complaint saying things don't exist. What if I try let's try renaming a folder. Okay, same thing. Same thing. This is weird. Swift run temp to X. From this to this. Okay, so the error is happening as in the place that's what we expected. Well, what we thought, but not expected, but not surprising, not from some surprising places. Ah. So what's the problem? POSIX rename enoint. So this is what it is. This it's node, right? So they're just like, instead of you're renaming the file to this, from this to that, this only work if this already exists, and it doesn't. Okay, what if I rename Swift run Maker releasing to releasing? Okay, so far none of the rename worked on POSIX at all. Sorry. And there's only one definition of it, right? Okay. Yeah, I don't get it. Rename. This is the Linux example. So enoint could, I think, means the old name doesn't exist, which is kind of funny. Yeah, I don't get it. Oh, what? Okay, this music is terrible. Because the style changes too much, right? So how can a thing as simple as this fail? So the result is not 0, it's -1, which is a failure. So we're throwing something that makes sense. And then something happened to be 2, which means no source, which means the file doesn't exist. How can the file not exist? Is this system integration, integrity protection thing? And this is the source, and this definitely exists. So this is a lie. I just don't get it. Okay. What if... Whoa. What was that? Wait, this is weird. This line is causing a crash now? What's wrong in absolute? That's weird. That's weird. What if we do LDB build debug make their releasing our okay. Let's try the debugger. Okay, we found this runtime error. This is the backtrace. Okay, so it's something that happens when we convert C string. Okay, this could be something that's from the trunk development. So I'm gonna switch back to how do I do this? Switch back so that we're using the production Xcode. Okay, so Swift. Okay, 5.2. Let's try this again. Okay, we have the same issue. Okay. So something about I don't know. What if I simply print absolute B string? Is there a dot string? Or just, I can just print this. Okay, that's concerning. Wait, is it concerning? Yeah, I don't know. Oh, why would this not work? This came out of nowhere. Okay. You know what? Let's try this. I'm gonna go to the temp directory, make a new project, right? Test pathos test. Pathos test. Swift package init. No, actually. Packages. Let's make this a executable. Oops. Okay. Now, let's make the dependency for, I don't know. How about HTTP GitHub 1 pathos 0.3.0. Then we make this target depends on pathos. Can delete this guy. Yeah. How about that? Let's get rid of this. Okay. And then let's make sources. Well, let's delete tests. And then move Well, let's just open up Vim, move this file so that it's actually main.swift, and then we'll import pathos, and then we'll literally say move path, right? Move. I think it's like move path from path command line arguments zero to path it's literally something like this. What? I thought I was editing this file. Okay. Swift run readme to readme. Wait. Pathos test readme. So it's not from path. It is. Ah, okay. I'm really curious. Like, is this just not working? Wait, it didn't work. What the heck? It just straight up doesn't work. Wait, now this binary doesn't exist anymore? Wait. I'm so confused. Wait a minute. I know what's happening. I think. Yeah. Did I make the same mistake here? No. Okay, so this I think just worked, right? Yeah, I think this just works. No, I didn't mean to launch the Swift repo. Let me out! Okay. Okay. Swift build. No, that doesn't work. But this will work, right? Yep, totally works. So what is the difference here? I think the difference must be, it has to be, the fact that pass plus POSIX. It has to have something to do with the C-string implementation. POSIX, binary string, C-string. What is C-string here? So C-string is the contiguous array plus 0 converted to buffer pointer. It doesn't seem really bad. It doesn't seem bad as far as C-string goes. This value looks okay. I mean, a workaround I can try is, let's just use absolute dot string or description. Okay. Build. Oh, that worked. So it has to have something to do with my stupid C-string implementation. That's super interesting. Okay. So this is not a good way to do C-string, apparently. And also that interesting crash we had is also indication that this is not great. So what is it? It's working because I think I didn't revert this to C strings. Let's revert it back to C strings, so it doesn't work. Check out release, sing. Okay. Binary string. So this is wrong. I should just throw this away like a hot potato. Okay, I'm just gonna do a bunch of random things here. So here's the result. Let's return it, right? And then let's try run Sterling on the result. I hope this is possible because well, it's possible now because I'm going to import Darwin. And then for C, yeah, I don't know. What is the right way to do this? Let's look at some documentation, shall we? With unsafe buffer pointer. Yeah, this is interesting. We are potentially running into some lifetime issues, which is understandable. So this is not actually a pretty bad way to do this. So let's try to do the right thing first. Pass plus POSIX. Yeah, that's not a great way to use. This is a pretty basic, like Swift thing. What if I do? Yeah, let me just try different things, right? So our ultimate goal is to call rename with 2C buffers. So what if I do binary string plus 0, right? This guy with unsafe mutable buffer with unsafe buffer pointer. Right, and then this will give us the from buffer. And then we'll do the same thing for the target, new path dot. And this one is the to buffer. So now let's call rename. From buffer dot base address to buffer dot base address. If this is not 0, we will throw. What is the error? Call can throw. All right. This is a pretty interesting problem, actually. I think he's also problem in a different place, in a bunch of places. So we can solve this. We need to do some dramatic stuff. Okay, it didn't work. So it's not a lifetime issue. Okay. What if I don't add this? This now has no way to work, right? I don't know why I keep hitting the Command H here. Okay, no chance that works. Okay, let's do more random things. So this guy returns an unsafe buffer pointer. Just let's just stare at it for a little bit. Wait, I'm really confused now. Why? Where's the print? Oh, this is the Windows version. Oh my god. Stop. Okay. You must be kidding me. Oh, I'm not using C string anymore, am I? Okay, revert everything back. 16 characters. Okay, for C in $0 print C. Let's print out every character. Why not? Or every number, rather. So it's a bunch of numbers ending with 0, right? And if I know the fact that I know, for example, if I say string C string $0, it should give us the right value here. I keep hating this hotkey, it's driving me crazy. Because I've been using the Windows terminal for a little bit and forming this bad habit. Okay, so this doesn't work, so we need to give it the base address. And we need to unwrap it or do this. Nope. Just unwrap. See, the problem is I have no idea if that's the right length. So what if I do okay, so there's no extra character towards the end, right? $116 looks a little suspicious. ASCII table. $116 is the letter uppercase N, so there's no way this is correct. Wait, really? Octodecimal 116. Oh no, it is correct. It's T. Yeah. Okay. So this is correct ASCII values. And I know, for example, if I don't include this 0, things will be chaotic, right? No? Oh wait, I'm using a wrong example. Hold on. Let's use a better example. Releasing okay, we're still failing Uh-oh. Sorry, one sec. Something's wrong with the stream. I don't understand. For some reason, the stream on Facebook just randomly disconnects. Alright then. I guess we'll just not stream on Facebook. Okay. So far, what do we have? It doesn't seem like this is something special. There's something special about the parameters rename take, right? So what's funny is if I convert our input from C string to a Swift string and use Swift's automatic string to UTF-8 buffer conversion, things work just fine. So can I do... string decoding? Oh, can I with memory rebound to UTF 8 dot code unit, right? Dot self $0 dot count. And then I make this into a string like so. String decoding as UTF-8.self and C string. Actually, this is a good way to implement this. Right? I don't know. Oh! What? I don't get it. So for some reason, if I don't add the trailing 0 here, everything just works? That's super suspicious. How can that be safe? So unsafe buffer pointer doesn't guarantee that the end is a 0, right? Yeah, see, this is a good warning. Like I'm not heeding this warning, so that's bad on me. I need to fix that. So this is really scary because I'm returning a contiguous array that doesn't end with, I don't think at least, it doesn't end with 0, right? And then I'm passing it to a C API that expects a 0 at the end. But for some reason it's okay. At least it appears to be okay. So that's the scary part. Right. Check out this. Run that again. So that succeeds. Check it out again. What is I'm super curious. How does this work? So whenever this works, it means, first of all, this is just wrong. I shouldn't do this. This is just violating what the documentation tells us to do. But whenever I do this, so things appear to be working. So it's possible that the end of the contiguous buffer happened to be 0. So, but why would it happen to be 0? So let's start from the beginning. Let's go to the call side. The call side goes, we're gonna create a path with a string, all right? So let's go to path.swift and look at the initializer. The initializer does, when it takes string, it calls pure path. So that's a pure POSIX path. And it takes a string somewhere, right? String, there we go. So that in terms calls POSIX binary string, which is just a contiguous array, POSIX binary string. So this leads us to here, which calls this minus the last. And we know that this value is an array with the 0 at the end. So we deliberately dropped the 0 here, right? Let's build, move. Yeah, so there was a 0, we dropped the 0. Yeah, so later it becomes like this. And that's got printed out here. Same thing here. So this is when we go from Swift string to binary, and then this is when we go use the binary in the C API. Yeah, I don't know. This just feels unsafe to me. Even though things are working, I don't think this is what we should do. I really need to understand why adding a 0 at the end is bad. That is what I really need to understand. Yeah, let's... Okay, just for fun, let's include the 0 here. Let's not drop it. Just for this purpose, right? Because I know that I'll wreak havoc in throughout the library. But I think in this case, it should just pass through, meaning this value, this contiguous array, once it's created, it should stay the same until being used here. We have enough trail here to observe that. So I'm gonna check out releasing. I'm gonna delete these random files. Let's just delete them visually, if I can. Hello? Okay. Okay. And then build. Then let's run it. It worked again. Okay, let me try this. Print self plus 0. Brace everything, and then I guess type of. I want to make sure this is a contiguous array as well, right? It's contiguous. It is contiguous array. So I'm gonna go back to drop last. Okay, and here let's go back to self plus. And then okay. Okay, this music's a little much, isn't it? Okay, so we're back to having this error. Wait, this is wild. What happened? What is this value? What? Decoding as... Wait. Decoding C string. That didn't work. Okay, decoding. What about this? Oh. Yeah. Oh, it became absolute path. Because I asked it. Okay, let's not do that because it confuses me. So here's our input with the zeros at the end. Here is the actual value. Here's the value with 0 at the end. Here's the contiguous array. And here are the other value. Okay. Oh, let's do something silly here. How about while let b equals this, b isn't 0, print b. Oh, just goes. Oh, wait. No. Base address. That's wrong. Base address. Advanced by bar equals 0. I. So like a basic C string handling algorithm where we'll just walk down the whole thing. Base address, right? The question mark belongs here. Okay, so if you just look at it as a C string, it has a reasonable value as well. 82, 69, 76, etc., ending with this. Oh, it is a lifetime issue, maybe. So I literally just So this did work, right? So this is a lifetime issue. Okay, okay. That actually makes me feel pretty good because otherwise I would be pretty confused. I was doing a bad thing? No, I am not. Okay, who else is printing? Okay, it's here. All right. So that just works. Okay, okay. Phew. Oh my god. Okay. So I better do the same thing on Windows, which means, okay, this is gonna be a interesting string. I think it might be when we end here. After this, I mean, how many of these am I using? It's everywhere, right? It's here. What is correct stat? Yeah, it's here. And then it's here. Then it's here. Oh, bunch of places, obviously. And it never had issues until now. So what is this? Line 19. Okay, the good thing is I feel like every function use it one time. Well, except here, I guess. Even here, it's not that terrible. So I need to do something to fix this lifetime issue. And that could be the main content of this stream, right? Like the implementing move is just a red herring that took us 2 hours. But in the end, we discovered the issue and then we realized our mistake and we fixed our mistake. Which is not a terrible thing. So if I were to go to binary string and change the signature to something like func C string action, and then this is gonna be something like this. It's gonna be a T, right? And then return the T. Okay, so here we call action I think this is where you say rethrows. Single argument function requires parentheses. What? Okay, here we go. Build errors. Oh, there we go. What's this? Oh my god, stop. Okay. Now we just need to fix all of these use cases, I think. So let me just close this now. Swift build here. Aha, okay, let's go. Return binary string dot c string scope binary Okay, so that's one. Here's the next one. Okay. I guess we don't need to return anything here. Oh, this whole thing needs to be in here, huh? Or I guess this doesn't need to be in there. Okay. So this one, I think it's okay. It's limited to a local function. So the block, the pyramid of doom is also kind of localized. C string in. Okay. Okay, we're getting close. Cause like these errors are showing up from top to bottom. And that happens to be the order we've been implementing. So now it gets more and more recent in memory. C string in. Okay. Put this in here. Delete these. And then do this with try. Literally same thing here. Well, okay. Oh, that's it, huh? Okay, so we're done with POSIX side. We have to do the same thing over again on the Windows side. Oh. Interestingly, we only touched a few files. It's not bad, not bad. So, yeah, I'm kind of, I don't know, this binary string business is a lot of effort for some performance. So I'm not regretting it, but it is very hard to do correctly. But let's do it for Windows as well. And the key difference here is our encoding unit is a 16-bit unsigned integer. Everything else should be identical. Okay, so the reason it's implemented this way as opposed to like a generic or something is because I do this. I hate when people do this, but the reason is, as opposed to the reason is because those are redundant. The reason is POSIX binary string and Windows binary string are type aliases of the same type with different generic parameters already. Okay, so what is the best way to do this? I can do something like this, right? Then kind of just eyeball it. Like, it looks like everything's in the same place, right? What if I just search for .cstring? So there's one, 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 there's one. Oh, here are a bunch. Yikes. Okay, it's fine. All right. Oh, this is a big one. Okay, so that's one of the C strings taken care of. I think I need to call it something else. Pass C string. Okay. Then inside here, I believe there's another use case, maybe. Or not. Maybe not. Okay. Feel like I forgot to write try in a few places. You know what? I'll just eyeball this part, and then we'll switch to the Windows machine, and then we'll do the rest over there. This is the plan. Try C string. Going here. Okay. Temp C string. Oh, this is the same thing again. Okay. Take the binary string dot c string. Oh, this needs to try as well. Let me add it up here. Okay. Suppose I can get this out here as well. Oh, that's okay, right? Because I changed the scope where handle is closed. It was actually a smaller scope. I'm happy about that. Okay. Just eyeball some Yeah, so I really am not happy about this converting the contiguous array to C string by adding a 0 at the end deal. So I think that ideally, I talked about this in the past stream as well. Ideally, the way to do it is you take the contiguous array and you store it with the 0 at the end. And then when you don't need it, you expose a view of it that doesn't include the 0, right? So that's the way to go, in my opinion. Oh, wait. That doesn't look right. Where is that? 155. Binary string dot C string temp C string. This has to be from C string, right? Okay. Implement move. Also fix incorrect usage of unsafe. Fix incorrect lifetime for C string for unsafe pointers. Okay. Yeah, just push it up. I'm gonna switch scene next. Switch scene to Windows Terminal. Okay, there's the Windows Terminal. Here you go. Make this nice and big. Can I increase the font? Yes. Not too big. Okay. All right. So let's go here. Check out move. It's up to date. Okay. So script shell, and then let's go to PowerShell. Script make, script build. So this is where we find out what error we made. Well, this is not an error. This is just a fortunate thing we need to deal with. Okay. Build. I'd be shocked if everything is correct. Okay. Has plus. There's not as many errors as I thought. Script build. No? Was it like CMD -C scripts to build on that? How about this? No. Okay. That's fine. We will just try this. Okay. Script, build. Okay, I'll just look at the error on the left and edit on the right. So this is in line 35. Aha. So the defer gets executed immediately, so we can delete the defer. Does that make sense? What we did is we open the handle. If it's invalid, we throw an error. Otherwise, we throw the handle. Right. That makes sense. Because our goal is not to use the handle itself. Is to read the metadata that came with the handle. Okay. So that's one warning out of the way. Then there's an error, I believe. Oh, there's a bunch of errors. Okay. 174. $218. Was this binary string dot C string? I believe so. And just like that, we're building. Now, what happens if I run all tests? Do test even build? We ran 162 tests and they all passed. That's pretty great. Not gonna lie. So let's check in some stuff. Okay. Fix. How about I think this is amend. How do you amend? Okay, so I think I amended. Now we can probably switch back to our other scene right here. Okay. Oh, that was quite something. I think the ultimate solve is make the binary make it so that I don't have to attach the little zero at the end. Aha, so I need to drop this. Okay. Interesting. So we need to drop this changes to the sample apps. Let's just run tests while we're here. Everything passes. Run tests in Docker. I don't expect anything different. We'll see. Cannot convert value of type this to expected type this. It's in binary string, right? think this is one of the implicit unwrap thingy. Glibc. Oh, we have more to convert. Cause yeah, this is one of those things where we actually have 3 implementations in some cases. Cool, cool. At least I don't need to switch machine for this. There we go. There it is. Okay, so we need to do this. And C string in throw. The rest in here. And then Bob is your uncle, as they say. Oh. Swift test. Oh, make test Docker. Glad I really didn't think I would run into anything in Docker, so I was really glad that I ran the Docker tests. Just saves a little bit of time of finding it out later on CI, right? I think everything else should be okay. Cool. It'll be great if this is 2 separate commits, right? Okay, let's do this. This sounds fun and less boring. I'm gonna push this guy up to GitHub before I do this next thing, which is I'm gonna reset to the previous commit. And then let's checking one thing at a time. Okay. Yeah, so starting from this file, everything here is good. And then in this file, we made some modifications, right? So these are all good. Glibc, yada, yada, yada. Make directory, move. But move is new. Wait. What's the last commit? Oh, there were 2 commits. Wait. Okay. I know this is guaranteed to be good. Okay. This is good. This is all good. Make directory is good. This is where we want to split up. Split again? No? Okay, let's edit. I think for the ones that we don't want to add, we just delete them, right? So that means Where does the parens end? So definitely don't want any of this. Okay, and guess to make the parens match up, we'll do this. Okay. Metadata and set working directory. These all look good. Look good. Good. Split. Good. 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 Split. E. Okay, delete those. You don't need to add this at all. Is this right? I have no idea. That last little bit worries me slightly. So it was like, it was not here, was it? Oh, we just need to look at the rest. So this definitely doesn't look correct, right? No way this looks correct. Okay. I know what to do. Move. Okay. Nice. So this first commit, we fix C string lifetime pointer lifetime. And this second commit, we implement passed up move. Okay, nice. So binary string dot C string previously returns an unscoped pointer to its storage, which is against recommendation of Swift documentation. Fix it by exposing the pointer to right over it. New path. One 7 4. Okay. All right. I think I'm gonna end the stream here. Thanks very much for watching, and just a reminder, I stream on Twitch. I prefer you watch there, Daniel_Duan. And if you're watching this on YouTube, give this video a like and subscribe to my channel if you want. And there's more goodness like this in the future. Thank you very much for watching. See you next time.